Okay, welcome to week 9. The thing we're going to be working on this week is going to be basically our second to last topic. It's going to be a few more methods in chapter 7 of the book, a few more Krylov space methods in chapter 7. Really, next week is also going to be Krylov spaces, but we're going to be looking at chapter 9 this week, which are sort of some modifications of stuff we've done so far for the Krylov stuff. One thing that I do want to point out. This is obviously a gigantic area of applied mathematics. Even though it's in one sense it's very narrow and specialized and technical. As we have seen, there are many methods. As we've seen in the discussion posts, there's a lot of stuff that we're not even talking about, that I haven't even mentioned. There's stuff in the book that I haven't even mentioned, and there are things that exist that are not in the book. So there's a huge area of math. So just to give you a little insight into how I'm choosing the topics that I'm choosing, a lot of this is based on the methods that are available. So what I mean by that is, if you look at the SciPy, the SciPy sparse linear algebra library, I'm trying to look at I'm trying to prioritize teaching you about the methods that are implemented in that library. If you look at the Deal 2 differential equations library, it has a whole bunch of solvers. I'm trying to show you the iterative solvers that are involved in that library. Now, a question could be asked, why are you showing us the methods for which there are implementations in these libraries rather than spending time on showing us methods that aren't implemented? Because if they're implemented, I don't have to implement them. But if they're not implemented, those are the ones that I need to know how to implement. Well, I am showing you some of those things, but the other thing is that the object that I want to sort of one of the main things that I want to show you guys is these methods exist. Here's how they work, and hopefully that is going to let you, first of all, be aware of them, and second of all, have an idea of which of these methods should be the ones that you're using. And like next week, for example, when we talk about preconditioning, you'll have a better idea of which preconditioners are going to be the best ones to use and stuff like that. Okay, I mean, obviously, when you are taking sort of a very applied math class like this, where you're implementing the algorithms, somebody else is almost certainly going to have implemented it better than we can, because they are spending way more time doing it. And so the idea isn't always to show you the tools that don't exist, but to show you the tools that do exist, which lets you understand those things better. So that is sort of my motivation for a lot of the things that I'm picking, and also the interfaces to the programs that I'm writing as well. I'm trying to make my interfaces match as much as possible to what exists out there, so you're comfortable with using the things that already exist out there. Anyways, there's a couple of modifications that I'm going to make to the final project. I mentioned it before. I will have those modifications done by today, which is Monday. It's not adding anything, it's subtracting some things. So for example, I was making you implement the givens rotations for the GMRes methods. I'm not going to do that anymore, stuff like that. Anyways, today is Monday. After today, the project will be stabilized, and like I said, I'm not adding anything. I'm just taking a couple of things away that turned out not to be things that I thought. There's other things I'd rather you spend your time on. Okay, see you in the discussion posts.